All right, we're live. Yeah, we are now live, coming to you live from room 903 at New Braunfels High School. Do your math homework. What? Do the whole thing like that? Like in my halftime band announcing voice? And the monastery of the week is Thomas Schreiber. I read that wrong, right? I read that wrong. I did throw out two shout outs to Mr. English's father-in-law on Saturday night. I don't know if you heard it. Right after I announced the Montessera's teacher of the week is, and then I said, and the Buford Hauler of the week is Mr. Weldon Price. And at the end, I said the band is direct run by the one and only David Eckert and blah blah blah. And the Unicorn Haulers are run by or managed by Mr. Weldon Price. I said it twice, so it was good. Raise them up, raise people up, right? So, what will I say next Friday night? Was it Friday night?
Yeah, it was
It
Friday night.
was Friday night. Oh, it was just, it was a football game. Were you there? It's okay. You don't have to watch football. The game goes on without you, Schreiber. Yeah. This is the first time we're going to the second round of the playoffs since like 2009, and it was the first time we'd been to the playoffs since 16, right? So it's been a while. It's been a while. All right. Miss Weaver's getting a little bit angry. She showed up for math today, and we're not doing math, right? Angry eyes, right? I know, right? Ready? Let's go ahead and type it into the calculator, right? Clear y equals. Does anyone in here have an 83? No one in here has an 83, right? So everybody has math print. Everybody has math print, okay? You want to always type it in exactly how you see it, okay? So 2, right? Go to y equals 2. Caret, right, above the division bar, x, 2 to the x, 2 to the x. I always click to the right. That kind of puts you on the far end of anything you type in. And then before you graph it, we're going to do it one at a time here. Compare it. Does it look the same? Yeah, it does. Even the color matches, right? Now, if you want to hit graph, resist that urge, right? Because that's just like, I'm not thinking. We want to think. So when you don't know what a graph looks like, or a good place to start is to hit zoom, right? We talked about hitting zoom first instead of graph, and number 6. So zoom 6, you should just be able to type 6 instead of scrolling down and enter. Zoom 6, right? That's your negative 10 to 10 window. Negative 10 to 10 on the x-axis, counting by ones. Negative 10 to 10 on the y-axis, counting by ones, right? Ooh, ooh, right? There it is. Now, remember what we did last time. You can actually evaluate functions from the graphing screen, right? What would the y-intercept of this graph be? 1, right? 1. And we can get that for two reasons, right? We know in the form a times b to the x, that would be 1 times 2 to the x. So the y-intercept is 1. Or if we wanted to compute it, what would we plug in for x? Find the y-intercept. A 0, right? So f of 0 is 2 to the 0, and 2 to the 0 is 1, right? So remember from the graphing screen, you can hit trace, trace, trace. And by default, when you hit trace, it does try to put you at x equals 0 if it's in the domain. Is it in the domain? Yeah, so we can see the 1 down there. So that's a confirmation of something we already knew. And text is already 2 sections ahead. That's okay. That's okay. It's okay. There's a dual credit course. Maybe you should be in that one. That's fine. You're just too smart for me. Sorry. Slow it down. The stories, you find the stories boring? Okay. All right. Good things come to those who get ahead. That's fine. Get ahead, right? Get ahead. What's the function value at 1, everybody? What should the function value be at 1?
1.
No,
0.
no. You're not thinking. You're just calling out numbers. You're no longer the Montessori of the week. F of 1 is 2 to the first, which is what? 2. Remember, we could verify that. If you see numbers down here, just numbers, and it doesn't say like x-intercept or intersection, you're in trace mode. You're already in trace mode. So you can just type in a 1, boom. It says x equals 2, right? And again, what's nice is you get the ordered pair, but you also see it blinking. It's like, here I am, look at me, I'm over here, right? What is the function value at 11? Type in 11, hit enter. What do we get? Uh-oh, quit, right? We don't press quit because we don't want to quit. Do we ever quit? Sisu, baby, right? Sisu. Um, I guess it's DNE, right? 2 to the 11th is DNE. Darn it, it doesn't exist. No, why do we get an error there? It's not in the window, right? So there's drawbacks to doing calculations like that from the graphing screen. It has to be in your window. So now you can hit quit, but it's just temporary quit. And you can go back to your window and change it to include 11 or go to your home screen, right? Second mode always takes you to your home screen. And if there's anything in there, hit clear, right? Flush. How do we do computations on the home screen? How can we access the function we have in Y1 from the home screen? Oh, I do the very bars, Y bars? Okay. Let's review the shortcut first. You remember the long way? Yeah. Yeah, alpha trace, right? When you hit alpha trace, you'll see it has the little tabs here. F5 is not activated, but in F1 you have your fractions, right? So that's where you get your horizontal division bar. This is a bunch of function computations. Like there's like absolute value in there. There's log based. There's some calculus things in there. Then you have your matrices, right? Where if you want to take a nap, this is where you go. The matris section. You did the matrices in algebra 2. We won't do that. And then you have your y variables. That's what that stands for. So we have our equation in where? Y1. So we'll just hit enter, and there it is. So we do that like function notation, right? Y1, open parentheses of, let's do 1. Yeah, 1. And we'll see if the calculator gets what? It's supposed to get what? Close parentheses. She'll get 2, because that's like f of 1. Hey, way to go, calculator. Boom. Let's try the 11. Let's do 11, right? Alpha trace, enter of 11. All right, now be careful. We might get an error again. Put your safety goggles on. No, it gave us the answer. You know why? Home screen don't care. Home screen don't care what graph screen is, right? They're two separate people. Okay, so the home screen has the advantage of you could calculate it for any X value you want as long as it's the domain. It doesn't have to be in this nice window. Okay, that's one of the advantages. Another advantage to this is you can do a series of computations without having to write anything down on the intermediate. So for instance, if I wanted to know what is f of, how about f of 11 minus f of negative 11, right? We would still write that down on our paper because that's indicating our method. That explains to someone what we want to do. But if I just want a decimal answer at the end, I don't want to have to calculate by hand 2 to the 11th power and then 2 to the negative 11th power and write them down and then come back and subtract them, right? Because when do we want to use a rounded or a truncated number for a subsequent calculation? Never, right? Never, if we can help it. So once I write it down, I could go I can go alpha trace of 11. And right there, I could just say minus alpha trace of negative 11. Okay. So remember, if you're subtracting two things, you use the subtraction button, right? But if you're naming a number or you're starting with a negative, that's the negative symbol. There it is. Your calculator will find those values, store them in its own memory, and then it'll subtract the 2. So then all we have to do is write down 2047 point, how many decimals? 3. 999 if we truncate, right? 999 if we truncate. What if you rounded? 2047 point what? 0, 0, 0 if you truncate. It would be an 8. And then this would be 5. And this would be a 1. And this would be a 3. Let's just raise your hand if you're a fan of truncating. There you go. Guess what College Board permits? Truncate. You're just reporting this answer. Um, 3 decimals is enough, round or truncate. Yeah, but you would have to round up again. You'd have to like 9 bumps up to a 10, bumps up to a 10, all the way through to the ones place. You're right. Truncate, baby, truncate. Now, what if what if I wanted to use this number later on, like tomorrow, or like in 2 calculations from now? I don't want to have to come back and type this in again. So what could I do with this? Stow it, right? So if it's on the previous line, there it is, with all the decimals fully intact, hit stow. And then which variable do we choose? Anything but what? Don't choose X, right? Don't choose X, because your calculator automatically default stores everything it finds on the graphing screen, which we will be using, to X. So you have all the other letters of the alphabet there, right? In green, A, B, C, D through the Z, I think, except for X. What letter do you want to choose? Alpha M for Matty, right? Right? Or for master photographer. Yeah. Hey, let's give it. She's been stepping up. You know, Mikey Farias hasn't been able to be at a couple of events because Worst Fest opening, and then he was in a car accident actually on the way to Friday's game and couldn't make it. But guess who's been stepping up, taking pictures and sharing them with people? She's been taking pictures of Ethan, right? And did you know she's taking pictures of you? Yeah, you knew that? Yeah. So let's sing the Happy Pencil song to Maddie. Okay, 1, 2, 3. Happy Pencil. Wait, hang on, stop. With a little alacrity, please. Ready? 1, 2, 3. Happy birthday. Hang on, stop. Is it your birthday? Really? I get confused. It's like the ABC and Baba Black Sheep and Twinkle Twinkle. They all have the same melody. I get them confused, right? Twinkle Twinkle Little Sheep, Baba Black Sheep. Yeah. Ready? Let's do the Happy Pencil song. Ready? 1, 2, 3. Happy pencil to you. Hey, happy pencil to you. Oh, happy pencil, dear master photographer Maddie. Happy pencil to you. There we go. Hey. Thank you very much. Yeah. I told her it was even more significant at last Friday's pep rally when Mikey couldn't be there because of Worst Fest. She was there and she captured the Haarschnitten. She captured Mr. Engler cutting my hair. And those pictures to me now are forever priceless. Priceless. Yeah. All right. So we'll truncate. Let's store it as, I'm going to store it as E for Engler. How about that? I think that was his favorite number, E. Right? So alpha E, yeah, you could choose A. It's right below the alpha button, right? Like that would make sense, right? Calling it alpha A. It's first letter. It's right there under the alpha. It's easy to find. So remember, if you call it E in your calculator, guess what you want to do? You want to come over here to your iPad/paper, wherever you're writing, and you want to call it the same thing. Just set it equal to, don't draw the arrow. The arrow is calculator language, okay? The arrow in math means becomes or therefore, consequently. We're going to say it equals E. So there's a reminder to you that, you know, if you're like doing something later on, like 5 plus 7, I don't know what that is. It's 12. Okay. Oh, it is 12. Okay. And then what sine of E of 45 cosine of 4? What is that? What is that? I forgot what that was. What is that? Oh, it's that number. Okay. Right. You would like whatever. You're like trying to calculate you're comparing cans of beans in the grocery store, you know, and so you're doing this right now. Oh, I need that value. I need that value from earlier. Dang it. Oh, yeah, where is it? Alpha E. There it is. Still in there. Okay. We store values. Even if we think we're going to use them and we don't, it's better to have them stored than not stored, right? Okay. 3 decimals, story value. So we did all that on Friday. Was everyone here on Friday? So now we've had the lesson twice. Man, tomorrow might be a good day for a quiz. Maybe. You're always ready for a quiz when you come in, right? And you're flat out disappointed when we don't have one. All right. Let's go to the table now, okay? Because that's what it says. Create a table of values. Most of y'all come in with knowledge of a table because I think your teacher told you back in the day, and it's good. You can represent a function with data as well as a graph, as well as an equation. So if we go back to y equals, there's our function 2 to the x. You can actually go to the table, right? Which is the second option on graph. But going straight to the table is like going straight to the graph. Do we do that? Am I teaching you to do that? No. Okay. Think of like a dinner table, right? If you go straight to the table to eat, you're like, I guess I'm having wood for dinner, right? Yes, because what's in front of you? Probably all the stuff that's on the table. Your parents ask you to what? Clear the table and then do what before you eat? Set the table, right? And wash your hands. But set the table. We got to set the table before we eat. Table set, right there. See that? Table set. Second window. Second window. Second window. Yep, second window. Now yours is probably set up, I don't know, whatever. -5? Yeah, that looks good. -14? Oh, those are fantastic numbers. All right. Let's go ahead and set it up to be, I don't know, where do you want to start? 12? -18? Yeah. I would start somewhere in negative land. What does our standard graph screen go to? -10 to 10. So yeah, we could do -18. -18. And then your delta table is, what do you want to count by? It's probably default at 1, which is fine. When you count by ones, those are friendly numbers, right? But you can change it to be whatever you want, like 0.5. We'll count by halves. Now, if you go to the table, once you set that up, you're good. But let's talk about what these are real quickly, okay? Because I don't think you've ever messed with these. If you keep them on automatic, that's good, right? What this does is if you keep both of these on automatic, is it's going to automatically generate values in the X column, counting by halves, right? -18, -17.5, -17, -16.5, so on and so forth. And then it'll automatically generate those Y values. So you'll just have a list, right? What's cool about the independent one is with the ask is you can actually flip it over to the ask, right? Flip it over to the ask. Go to the ask and hit enter. Now it's highlighted. When you do that, everything you just did above with table start and delta table, it's gone. It throws out the window, okay? Let me show you why. Leave your dependent variable on automatically generate. Generally, we leave that one on auto because if you put it on ask, you're going to have to hit enter for it to give you the value. We want it to just magically appear. But look at the independent variable. Go to your table now. Hit second graph once you put it on ask. It doesn't generate anything. In fact, it's sitting there in the table and it's not blinking. It'd be cool if it could blink, right? But you know how you get that thing to blink? You just blink your eyes and it looks like it's blinking, right? Right, you can simulate it on your end. It's waiting for you to type something in. Anything, like a 0. What should I get when I type in a 0? A 1. Boom. Way to go, calculator. Let's put in a 5. What should we go and put in a 5? What? 32. Good, because that's 2 to the 5th. Boom. 32. You go, calculator. Another one. 11. Okay, you just put 11. Boom. There it is. So we've seen all these numbers already, right? Very good. These are the ones we did on the home screen. So this gives you another way to compute Y values of a function. You can either do it from the home screen, Y1 of, or you could generate them like this, okay? Now, let's talk about funky numbers. These are all nice little integers. What if you type in like -5.3? Look at that. Do you think it's 0.02538? The column's kind of narrow, isn't it? Guess what? If you come over here and you highlight the number and you look down below, you're like, oh, there's a lot more decimals, okay? A lot more decimals. So it's cool that you can generate values that don't have to be in the table or in the window, but you can't store them from here. That's bad. And guess what else you can't do from here? You can't do like Y1 minus Y2, okay? That's just for generating individual values. So we still would prefer to do it from the home screen, okay? We would still prefer to do it from the home screen for reasons like this. F of 11 minus F of -11. You can't do that from the table screen because you're going to have to write down things and the decimals might be ugly. And we don't want to use the truncated or rounded number for subsequent calculation. But you could do it, right? Pretty nifty. All right, so let's go back to table set. If you, of course, put it on auto and then go to the table, there they are. Okay. It generates them automatically. And if you scroll over to the right, you can see those numbers right there. Now, the E, the capital E means what on the bottom there? When you see something like that, 1.5, blah, 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 E, 1.525 E to the negative fifth. That's your calculator's way of saying the same thing as 1.525 times 10 to the power of 5. That's its way of using exponentiation base 10, scientific notation. Okay, they mean the same thing. It's just abbreviated that way. Now, is that a big number or a small number? Small number, right? That's a 0 with a decimal and then 4 zeros, 1525. So it's small. Is that what we would expect at a negative value? Yeah, because remember, what would be the limit as x goes to negative infinity? 0, right? For these exponential growth functions, it's 0 as we go out to the left. And so there is a horizontal asymptote there, but it only affects the graph on the left because what would be the limit as x goes to positive infinity? As we go to the right, what's the graph doing? More money, more money, more money. It's going up to infinity. Yeah. Hey, let's see if we could break these calculators. Let's see. Huh? No, they're brand new. Let's jailbreak it maybe, right? Man, some kind of like, you got a pirate in the audience here. Let's go to your table set and go back to automatic or go back to ask. Okay, let's go back to ask. Let's see if we can break it now. Go to the table and let's type in a really small number, like a really negative number, like negative 99. That's way down the line, right? What does the calculator tell you? Oh, 2e to the negative 30. Is that big or small? That's tiny. Okay. That's not even a small number, is it, Teresa? How about negative 999? Now we're getting into like numbers I can appreciate, right? Like my debt, right? Oh, we broke the calculator. We broke the calculator. Liar, liar, liar. It's lying to you. Is it really 0? No. Let's see. If you scroll on top of it, maybe. No, it doesn't. We broke the calculator. It's like when you wrestle someone, you're like, you say I'm the best. No, say I'm the best. And then you hurt them real bad because you're wrestling. Okay, you're the best. You're the best, right? That's what we just did with the calculator. We put in like a number that was so small, the calculator was like, 0. Okay, fine. If you want me to say 0, I'll say 0. But you're not really the best. You just forced them to do that. It's not really 0, right? Now, that's breaking the calculator gently, right? Let's see if we can really break it. Negative 999, 9, 9, 9, 9, 9, 9. Now hit enter. Oh, it's still 0. Okay, all right. You two can play that game, calculator. Negative 99999999991, 99993, 999, 99999. I'm going off the screen here. 99999, 99999. Sing the 9 song with me. 9999999, 9999999. Okay, now hit enter. Oh man, I thought that was going to break the calculator. Sometimes you could break the calculator so bad it'll give you an error. Like it'll say overflow, usually is what it says. All right, let's try it going out the other way. We know as we go to the right, it's supposed to go to infinity, right? Let's plug in 999. Ooh, big number. Ah, that was too big. That's not even that big, right? Let's try like 99. Oh, there it is. It's 6. Is that right? No, it's 6 times 10 to the 29th. This is the power of exponential growth. This is the power of time value of money, right? Invest when? Late in life or early in life? Early in life. Because think about a doubling factor. You double a penny, you have 2 pennies. But you double $1 million, you got 2 million. That's right. Okay. So this thing grows so fast that it breaks the calculator. Now I don't know what the threshold is, right? 999 really broke it. What's bigger than 99 but smaller than 999? 500? Can it handle 500? No, it can't even handle 500. It grows way too fast. Okay. So that's breaking the calculator in the wrong way. That's your calculator's way of saying infinity. Weaver, are you still peeved? Is this, it's at least about math? No. Oh, okay. Anybody know any good Thanksgiving jokes? Why did the turkey cross the road? Oh, for me to answer. Oh, because it was trying to get away from the pilgrims. Oh, what? Free response, Joe. Yeah. Hey, why did the turkey was able to get away? You know why? Because the pilgrims' pants kept falling down. Because they had buckles on their hats. Yeah. Yeah. All right. Let's go ahead and do one last thing here. We're still on 2 to the X. How much time do we got? 5 minutes. Okay. All right. Let's try to stay focused here. Look at your graph. That's Zoom 6, right? Zoom 6. We see most of the graph. Let's see if we can trim it up a little bit, right? Like you're a butcher, you get in like a side of beef. You don't just put it out there. Here you go, consumer, right? You're in there, you're trimming the fat, you're customizing it. And then you're saying here, ooh, careful. Doesn't go back very fast. Okay. I don't think we need to see all this down here. Do you? This graph never touches or crosses the x-axis. There's a horizontal axis. So let's see if we can change the window to get rid of some of that extra space. Also, the local behavior that's of interest to us is the y-intercept. I kind of see the predictable pattern. It's turning into the x-axis here, and it's going off the screen at the top there. You don't want your graph to exit vertically. You want your graph to exit the screen if it does horizontally. So let's trim some of this up, and let's come in a little bit as well. All right. So let's do that together. We're going to go to window, which is at the top, and we're going to manually choose our left and right, X min, X max. -5, I heard. That's good. To 5, right? That's good. Horizontally, we're cropping it by a factor of 2, right? Okay, now your X scale, you can leave it at 1. That just puts a tick mark every unit, so that's not bad. Now your Y min, negative what? -5 is great. Very good. Why -5? I'm curious. Okay, it cuts it down by half. Oh, that's not bad. Not bad. Let's talk about why, though, the graph doesn't even live below the x-axis, right? So we really technically don't even need to see any negative. So 0 would be not bad at all. But I thought you were going to say this, and I'm still going to give you credit because you have this natural intuition, right? As all women do, guys. It's nice to still be able to see the x-axis because it is the horizontal asymptote. So seeing the x-axis can remind you that's a horizontal asymptote. But remember that your calculator uses the bottom and top of the screen to write on, doesn't it? Like when we hit the trace, it was putting ordered pairs at the bottom and it puts the equation at the top. You don't want the calculator to cut off your graph, do you? So you always want to have like a buffer space above and below. So -5, I think, is good. Now for the Y max, it exited off the top of the screen. We want to at least go up far enough so we can see some of that. So how do I know what Y value to put for my max? If I'm going from -5 to 5, at the right edge of the screen when X is 5, can I figure out what the Y value of the function might be there? When X is 5, what would the function value be? When X is 5, on the right side of our graphing screen, when X is 5, what's the function value? What's f of 5? Louder? No, that when you plug in a 5 for X, what's 2 to the 5th? You already said it earlier. 32, right? Does everyone understand what we're doing? Yeah. At the right end of the screen, when X is 5, what's the function value? It's f of 5, which is 2 to the 5th, which is 32. So let's put something that's a little bit bigger than 32 as a buffer, like 40 might be good. Yeah, there's really no wrong answer. You just do trial and error. Now your Y scale, I would always put that at 0. Okay, if you're stretching it out, because you're going to have too many tick marks and it's obscure the view. You get fat axis we talked about, right? And then you don't need to mess with anything after that. Okay, now just hit graph. We fine-tuned it. Oh yeah, and now it exits the right side of the screen. That's important because what that means now is in our desired interval from -5 to 5, we see all the y values, right? And now finally we have a way to graph the other function and compare it to this one. Yeah, window. -5 to 5, count by ones. -5. I went up to 40. Yeah, y max. Yeah, there we go. Good. Now we're running out of time, aren't we? So remember where we are. Tomorrow we'll graph the other one, and then we have the insight in how they're related. Okay. But right now we're learning how to use a calculator, right? Let it work for you. Who's the boss of the calculator? You or the calculator? You are. Go ahead and clear the memory if you remember, or at least delete it and put it back in the charging station and in the right slot. And we'll pick up there tomorrow. Tomorrow we're going to move a little bit more quickly. And we'll probably get to writing some equations of our own. Should be fun. Chariot Jubilee, everybody. Have a great day.